Welcome to C# serialization for beginners, an essential topic for any C# developer looking to manage data effectively. In this comprehensive guide, we'll explore the fundamental process of converting complex C# objects into various formats, making them suitable for persistent storage, efficient transmission across networks, or seamless preservation of application states between sessions. Understanding serialization is key to building robust and scalable applications. Serialization is a cornerstone of modern software development, proving crucial for a multitude of tasks. It enables the seamless saving of complex application states, allowing users to pick up exactly where they left off. Furthermore, it facilitates the efficient transmission of structured data across diverse networks, ensuring reliable communication between different systems. Ultimately, serialization is indispensable for preserving object data, maintaining its integrity and availability across various sessions and environments. Throughout this tutorial, we will delve deeply into three primary and widely used serialization methods, each offering distinct advantages and catering to specific application requirements. We'll begin with JSON, a lightweight and human-readable format, then transition to XML, a versatile markup language, and finally, explore binary serialization, known for its compactness and efficiency. Each method presents unique applications and benefits that are vital for different scenarios in C# development. First, let's explore JSON, which stands for JavaScript Object Notation. It's a lightweight, human-readable data interchange format that has become incredibly popular due to its simplicity and efficiency. JSON is widely used in modern web APIs for sending data between a server and a web application, and it's also a common choice for client-server communication in various other applications. In Unity game development, JSON utility is the go-to choice for JSON serialization. It's a built-in solution that offers excellent integration with the Unity ecosystem and provides significant performance benefits, especially for simple data structures. Its native implementation makes it highly efficient for common serialization tasks within Unity projects. To serialize an object using JSON utility, you first need to define your C# class and mark it with the serializable attribute. This attribute signals to Unity that the class can be serialized. Then, you simply use JSON utility.toJSON to convert an instance of your class into a JSON string, ready for storage or transmission. JSON utility is particularly known for its impressive speed and minimal overhead, often outperforming other general-purpose .NET JSON solutions when used within Unity. This makes it an ideal choice for performance-critical Unity applications where fast serialization and deserialization are essential for smooth gameplay and responsiveness. However, JSON utility does come with certain limitations. For instance, it does not directly support complex collections like dictionaries or nested lists without requiring a wrapper class. This means you might need to create additional classes to properly encapsulate your data structures before serialization, adding a small layer of complexity. For more powerful and flexible JSON serialization capabilities beyond Unity's JSON utility, Newtonsoft, JSON, also widely known as JSON.NET, is an industry standard and incredibly popular choice among C# developers. It offers a rich feature set and extensive customization options for handling complex serialization scenarios. After easily installing the Newtonsoft JSON NuGet package into your project, you can begin to serialize objects with remarkable ease and control. You simply use JSON convert serialize object to convert any C# object into a JSON string, benefiting from its extensive customization options for formatting, handling nulls, and more. Deserializing JSON back into a C# object using Newtonsoft JSON is equally straightforward and highly intuitive. You utilize JSON convert, a deserialize object, T, where T represents your specific target C# type, to parse a JSON string and reconstruct the original object, ensuring type safety and data integrity. When working with Newtonsoft JSON for serialization, it's crucial to ensure that your properties or fields are declared as public. This is because the serializer typically requires public accessors to read and write the data, ensuring that all the intended data is correctly included in the final JSON output. You gain fine-grained control over your JSON output with Newtonsoft JSON by handling null values and ignoring specific properties. For example, you can use attributes like JSON ignore to explicitly exclude a property from serialization or configure settings to omit null values, resulting in cleaner and more compact JSON. Next, we move to XML, which stands for Extensible Markup Language. XML is a robust markup language that defines a set of rules for encoding documents in a format that is both human-readable and machine-readable. It is often used in configuration files, data transfer between systems, and for defining structured data in various applications. C#'s built-in XML serializer provides a powerful way to convert objects into XML format. You instantiate it by specifying the object's type, and then you call its serialize method, typically passing a stream in the object instance, to write the object's data into a structured XML document. Let's look at a basic example to illustrate this process. Consider a simple C# class, perhaps representing a book with properties like title and author. When serialized, this class will translate directly into an XML structure, with each property becoming an XML element, clearly demonstrating the mapping. To deserialize XML back into a C# object, you follow a similar process. You create an XML serializer instance for the target type, and then use its deserialize method, reading from an XML stream. The result is then cast back to your original object type, reconstructing the data from the XML structure. You can exert significant control over the XML output by using various attributes. Attributes like XML attribute can map properties to XML attributes. XML element can rename elements. XML ignore can exclude properties, and XML root can customize the name of the root element, allowing for precise XML structure definition. For successful XML serialization using XML Serializer, it is a fundamental requirement that your class includes a public parameterless constructor. This constructor is essential because the serializer needs a way to instantiate the object before populating its properties during the deserialization process. When dealing with collections and arrays in XML serialization, you can precisely define their appearance using specific attributes. XML array allows you to specify the name of the parent element for the collection, while XML array item lets you define the name of each individual item within that array in the resulting XML structure. A common issue with XML Serializer is the addition of unwanted namespace definitions in the XML output. To elegantly remove these, you can pass an XML Serializer namespaces object with an empty namespace to the serialize method, resulting in cleaner and more concise XML documents without extraneous declarations. Finally, let's explore binary serialization, a method that converts an object into a compact, non-human readable binary format. This approach is highly efficient for storage and transmission, as it minimizes file size and processing overhead, making it ideal for scenarios where performance and space are critical. The binary formatter class is traditionally used in C# to serialize objects into a binary stream. For this to work correctly, the class you intend to serialize must be explicitly marked with the serializable attribute, indicating that its instances can be converted into a binary format. To perform binary serialization, you first create an instance of binary formatter. Then, you use its serialize method, providing a stream and the object you wish to convert into its binary representation. Deserializing binary data back into an object involves a similar process. You create a binary formatter instance and then call its deserialize method, reading from the binary stream. The returned object, which is of type object, then needs to be explicitly cast back to its original C# type for use in your application. It's crucial to be acutely aware of significant security concerns when using binary formatter. Deserializing untrusted or malicious binary data can lead to serious vulnerabilities, including remote code execution, making it a high-risk operation if not handled with extreme caution and proper validation. Always ensure that any class you intend to serialize using binary formatter has the serializable attribute applied. This attribute is a mandatory requirement for the binary formatter to function correctly, as it signals that the class's state can be captured and reconstructed from a binary stream. Given the security risks and performance considerations of binary formatter, it's often advisable to consider modern alternatives like MessagePack. MessagePack offers superior performance, enhanced security, and cross-platform compatibility, making it a more robust choice for binary serialization in contemporary C# applications. In summary, we've thoroughly covered three fundamental types of serialization in C#: JSON, XML, and binary. Each method serves distinct purposes and offers unique advantages, making them invaluable tools for various data management and communication tasks in C# development. JSON stands out for being human readable, lightweight, and exceptionally well suited for web APIs and modern client server communication due to its simplicity. XML, while more verbose, is highly versatile for configuration files, document centric data, and structured data transfer, offering strong schema validation capabilities. Binary serialization, on the other hand, is highly compact and incredibly efficient in terms of storage space and processing speed. However, its non-human readable nature and significant security considerations, particularly with binary formatter, mean it requires careful implementation and often leads developers to seek safer, more modern alternatives. We encourage you to experiment with each serialization type to gain practical experience and determine which method best fits your specific project needs and requirements. Understanding their strengths and weaknesses will empower you to make informed decisions for robust data handling in your C# applications.